Black holes eat everything. But where does all that swallowed matter actually go? Scientists have discovered a terrifying possibility. The other end of a black hole might connect to a monster that frantically spits things out. It is called a white hole. It is the exact opposite of a black hole. Black holes swallow light. White holes violently eject it. Nothing can get close to a white hole. It even pushes time itself away. What is even crazier, some physicists suspect that our very own Big Bang was actually a supermassive white hole. What does this mean? It means that 13.8 billion years ago, we might have been blasted out of a black hole from an entirely different universe. Think about the ground beneath your feet, the air you breathe, every single atom in your body. They could all come from another universe. But here is the catch. If white holes are real, why haven't we found a single one yet? In 1964, Soviet physicist Igor Novikov was crunching black hole equations. He discovered a stunning fact. If you reverse the flow of time for a black hole, the math still works out perfectly. This time-reversed celestial body is the white hole. Instead of sucking everything in, it pushes everything out. Imagine a black hole as an ever-draining sink. A white hole, then, is an endlessly erupting fountain. Mathematically, these two objects are perfectly symmetrical. But in reality, this symmetry is deeply bizarre. You can enter a black hole, but you can never leave. Time only moves forward. In a white hole, the situation is completely flipped. You can never enter, but you can be thrown out. It is like standing in front of a reversed waterfall. The water flows upward. You try to walk in, but a stronger force pushes you back with every step. Even scarier? To an outside observer, a white hole seems to create matter out of thin air. Stuff just appears out of nowhere. This directly violates our basic physical intuition. It also breaks the second law of thermodynamics. In our universe, chaos only increases. It never decreases. For example, shattering a glass is easy, but the shards spontaneously reassembling into a perfect glass, that is virtually impossible in nature. This is called the law of entropy increase. It is one of the universe's most unbreakable rules. Yet, the matter ejected by a white hole seems more ordered than when it was absorbed. It is exactly like the broken shards piecing themselves back together. Because of this, most physicists dismiss white holes as a mere mathematical fantasy. They believe they cannot possibly exist in reality. But in March 2025, a research team from University College London published a groundbreaking study in Physical Review Letters. Through quantum mechanical calculations, they proved that a black hole's singularity might not be a dead end. Instead, it could be a turning point. When matter falls into a black hole and is compressed to its absolute limit, quantum effects trigger a bounce. Think of a spring compressed to the max, suddenly exploding in the opposite direction. The exit of this bounce is a white hole. In other words, black holes and white holes might just be two different stages of the exact same object. The black hole absorbs matter on one end. The matter undergoes quantum tunneling inside. Then, it shoots out the other end as a white hole. It acts as a giant space-time tunnel. This theory solves a mystery that has plagued physicists for decades: the black hole information paradox. Simply put, information entering a black hole is supposed to disappear as the black hole evaporates. But quantum mechanics says information can never be truly destroyed. This contradiction gave Stephen Hawking a headache for most of his life. But if a black hole transforms into a white hole, the problem vanishes. All the swallowed information is simply released during the white hole phase. What is even more mind-blowing? To an outside observer, this transformation might happen in a split second. But for an observer inside the black hole, it could take billions of years. Why? Because the extreme gravity near a black hole drags time down to a crawl. Italian physicist Carlo Rovelli, one of the founders of loop quantum gravity, even wrote an entire book exploring this possibility. He describes a breathtaking scenario. If you were to actually fall into a black hole, pass through the event horizon, and and approach the singularity, you would not be crushed into a point and disappear. Instead, you would experience an extreme warping of space-time. Then, you would be blasted out of the white hole end. You might enter a brand new universe. Or, you might return to some remote corner of our own universe. Of course, your physical body would have been torn into fundamental particles long before that. But your information, your very essence, would be reborn in another form. It sounds like pure sci-fi, yet it is backed by serious mathematical deduction. So, back to the big question. If white holes exist, why haven't we spotted one? Astronomers propose a few possibilities. The first is that white holes exist for an incredibly brief moment. They might last only a fraction of a second before collapsing back into a black hole. A white hole is an extremely unstable structure. Any slight disturbance in external spacetime causes it to instantly collapse. The second possibility is that a white hole's eruption is simply too energetic. It is so powerful that we mistake it for other cosmic phenomena. Take gamma-ray bursts, GRBs, for example. GRBs are the most violent explosions in the universe. In mere seconds, they can release more energy than our entire Milky Way galaxy. In 2006, astronomers detected a gamma-ray burst designated GRB 060614. Its characteristics were highly unusual. It didn't look like a supernova explosion. It didn't look like merging black holes either. In 2012, physicists suggested this could be actual evidence of a white hole eruption. This idea is not yet proven. However, it opens up a completely new direction for observation. If we can find more anomalous outbursts like this, we might finally catch a white hole by its tail. There is also an even bolder possibility. The Big Bang itself could have been a supermassive white hole event. Imagine this: 13.8 billion years ago, in some corner of another universe, a supermassive star collapsed into a black hole. This black hole swallowed all surrounding matter. At its singularity, everything was compressed to the limit. This triggered a massive quantum bounce. The energy of this bounce was so immense that it literally tore space-time apart. It created an entirely new universe. That universe is us. From this perspective, our entire cosmos might have been ejected from a black hole inside a mother universe. The earth beneath your feet, the starry sky above, every atom in your body, they might all be the legacy of another universe. This theory is called the cosmological black hole model. It was proposed in May 2025 by Professor Enrique Gastañaga at the University of Portsmouth. His calculations show something fascinating. If our universe originated from a black hole bounce, it should possess a faint, non-zero curvature. It would be slightly curved, much like the surface of the Earth. Furthermore, this model actually explains the origin of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. In this black hole model, dark energy is not some cryptic quantum field. Instead, it is simply the residual shockwave left over from the bounce itself. What is even crazier, this implies our universe might not be the only one. If we were born from a black hole, could the black holes inside our universe be gestating new universes right now? Inside every single black hole, there might be a rapidly expanding baby universe. They would have their own time, their own space, and their own laws of physics. We could never see these universes. They are forever locked behind the black hole's event horizon. Conversely, to an observer in our mother universe, our entire expanding cosmos is nothing more than a black hole. It is like a set of cosmic Russian nesting dolls, one inside another, endlessly infinite. Some scientists even propose that white holes could be linked to dark matter. Dark matter makes up 84% of the universe's total mass. Yet, we cannot see it or touch it. We can only detect it indirectly through its gravitational pull. Recent studies suggest that white holes might actually make up the bulk of dark matter. Why? Because a white hole neither absorbs nor emits light. However, it still has mass and gravity. This perfectly matches the exact characteristics of dark matter. If this hypothesis is true, dark matter is not some mysterious exotic particle. Instead, it is a swarm of microscopic white holes scattered across the cosmos. They could be the ancient relics of countless bouncing black holes from the early universe. Of course, all of this remains theoretical speculation. No white hole has been directly observed yet. But this is how science works. You start with a bold hypothesis. Then, you go out and test it. Decades ago, the black hole was just a bizarre solution in Einstein's equations. Many dismissed it as a mere mathematical game, impossible in the real world. But in 2019, humanity captured the very first photograph of a black hole. That glowing orange ring proved Einstein right. Now, it is the white hole's turn. Perhaps one day in the future, we will catch a white hole in the act of erupting. Or maybe we will spot a celestial object in a distant galaxy actively transforming from a black hole into a white hole. That would be one of the greatest discoveries in human history. More importantly, white hole research is pushing the boundaries of physics. To truly understand white holes, we must merge general relativity with quantum mechanics. Right now, these two theories heavily contradict each other. General relativity governs the macroscopic world of gravity and space-time. Quantum mechanics rules the microscopic realm of particles and probabilities. Both are wildly successful in their own domains. But when they meet extreme conditions, like black holes, singularities, or the Big Bang, the two theories clash. The existence of white holes might provide the ultimate key to reconciling them. It could help us build a true theory of quantum gravity. This is a dream physicists have chased for nearly a century. Furthermore, if a black hole and a white hole are indeed connected by a wormhole, we could theoretically use them for interstellar travel. We might even travel through time. You dive into the black hole end. You pop out of the white hole end. In an instant, you traverse hundreds of light years. Naturally, this is only possible in theory. The practical challenges are unimaginably huge. First, you need to find a stable wormhole. Second, you must survive the black hole's lethal tidal forces. Finally, you have to guarantee the white hole won't collapse before you make your exit. But who knows? Perhaps in the distant future, when our technology reaches unimaginable heights, this will all become reality. When that day comes, the white hole will no longer be just a theoretical concept. It will be a gateway to infinite possibilities. Now, let us return to our very first question. Where does everything eaten by a black hole actually go? The answer might be that it goes to a white hole. It travels to another universe. It reaches the other end of time. And we ourselves might just be the very things that were spat out. Our entire existence could be the miraculous rebirth following the death of a black hole. This thought is both mind-blowing and oddly comforting. It tells us that there are no true dead ends in the cosmos. There is only an endless cycle of rebirth. The black hole is death, the white hole is birth. Between the two lies an eternal loop. As physicist Carlo Rovelli poetically puts it, do not be afraid to walk into the black holes of your life, because we can always come out from a white hole. We may never know for absolute sure if white holes exist, just as we can never time travel back to the very moment our universe was born. But that does not matter. What matters is that we never stop asking questions. We never stop imagining. In this vast, majestic universe, every answered question hides a much deeper mystery, and every exploration brings us one step closer to the ultimate truth. Maybe one day, when we finally discover a white hole, we will realize something profound. We have never been looking for the end of the universe. We have been looking for a brand new beginning.